Verona, Verducos Lab, where is it? Verducos Lab. He will present the effects of localized neuromuscular fatigue on muscle synergies during postural control. The stage is yours.
Thank you, Gaspare, and hi everybody. As we know, muscle fatigue impairs our motor control because we reduce the force and the power we generate, meaning that we cannot do the same movement as coordinated as before, as smooth as before. So for this reason, we wanted to investigate the effect of fatigue on motor control, on postural control, using the model, as I said, of postural control, with two main questions. The first one is how does neuromuscular fatigue influence postural control, and we wanted also to investigate if fatigue has some effect on our learning processes. We're using the model of postural control, and to analyze this model, we use the mathematical method of muscle synergies. So muscle synergies are described as coordinated recruitment of muscles aimed to generate task-specific motor commands. So our hypothesis was that fatigue influences and modifies the contribution of the muscles, but it may also impair some parameters of the muscle synergies themselves, such as number of synergies, muscle weightings, or temporal activation coefficient. So our aim was to evaluate the effects of neuromuscular fatigue and understand how fatigue affects our adaptation during the learning processes, and we wanted to discover if we have some after effects after a recovery period. So in order to answer those questions, and in order to do the experiment, we recruited 24 participants, divided into two groups. The first group was composed of 13 participants for the fatigue group, and the second one 11 participants. We excluded subjects with musculoskeletal injuries at the level of the lower limb. The protocol and task is described in this slide. The subject came to the lab and had to perform a leaning body movement around the ankle joint, as you see in the middle of the slides, on a force plate, looking at the visual feedback on a monitor, and he had to shift his center of pressure from the home base to the target. The target was shown in 4 different directions, and the target was shown randomly. We attached 16 EMGs to the right side of the body, and the protocol was divided into 2 days. The first day, the subject came to the lab, performed the task, and got fatigued at the level of the tibialis anterior, and performed the task again. He repeated this cycle, let's call it, 4 times. And on the second day, 48 hours the first day, he came back to the lab and performed the task again without getting fatigued. So the analysis process starts from an EMG dataset, then to analyze the synergies extraction, and then the reconstruction of the synergies, and then we analyze some parameters of the synergies, such as the number of synergies, then the muscle weightings with different approaches, and then we will analyze also the temporal activation coefficient, that is a work in progress. So I won't discuss it now. As you can see, the number of synergies doesn't change significantly throughout the experiments, meaning that we don't change our coordination pattern for both groups, control group in blue and fatigue group in red. But if we look at the muscle weightings, starting from the sparseness, we cannot see a difference between groups and also within groups, meaning that both groups spread the activation across all muscles in the same ways, without directing the activation toward fewer muscles. But we want to dig deeper in this analysis of the muscle weightings, and we make some analysis of the subspace, on the subspace. The interesting result is that in the fatigue group, we have a tendency in changes the last principal angle, meaning that we have some rearrangement in the synergies. And if we dig deeper more in this analysis, we had done the cluster analysis using Kimin, and we found 4 different clusters. Each cluster contains the synergies that modulates for a particular direction. If you see, we have 4 clusters, 1 cluster for direction, but we will focus only on the backward and rightward cluster, in which we have the most significant results. As you can see there, we have the plot of all the muscles from distal to proximal, and then the muscles at the level of the trunk with 2 groups. In the orange rectangle, we can see the muscles that are different between groups. You can see the backward cluster, in which we have, for the fatigue group, an higher activation of the distal muscles, while they decrease the activation at the muscle at the level of the knee, especially for the rectus femoris, but we have also a tendency for the vastus. We also decrease the activity at the level of the soleus. But the interesting part is that if we look at the difference between group for each bout, so for each timestamp during the experiment, we can see that in the second day, so after 48 hours, after the day 1, after a recovery period, we also have significant differences between the 2 groups. And for the rightward cluster, it was quite the same, but with different conclusion. But we have an higher activation for the muscles at the level of the trunk, we lower activation at the muscles at the level of the ankle, tibialis and gastros, and we also have a decrease in the magnitude of the activation for tensor fascia latae and gluteus medius. And in the comparison between groups show that also in this cluster we have a significant difference that remain also in the second day. So the interpretation of these results is that we have different strategies between clusters derived from fatigue. For the backward cluster, we shift the activation from knee strategy to ankle strategies. While in the rightward cluster, we don't have a shifting, but we have a compensation, because we have a greater involvement at the level of the hip. On the second day, we increase the activity also at the level of the knee, so we use both knee strategies and hip strategies in order to overcome fatigue. And we have the tensor fascia latae and gluteus medius that stabilize the posture. So, in conclusion, we don't have a change in coordination pattern because we don't change the number of muscle synergies, while we have different strategies that allow us to overcome fatigue. For one group is shifting, and for the other one is compensation. In my opinion, it's different because in the backward cluster we include more the activity of the tibialis than in the rightward cluster. And we have also a long-lasting effect on the second day because an higher activation is seen also in the second day. So, thank you to my group, thank you for your attention.
Thank you, Giacomo. If you want, you can come back to the thanks the group. So all the people in the group are happy about that. I'm joking about that. Questions? I thought, bravo.
So Luca Ruggero from the University of Constance. So, is it possible that what you found in the second day was just a familiarization effect with the task? If I understood correctly, on the first day they did the fatiguing task, and then on the second day they came to the lab again. Is it possible that on the second day they had figured out a strategy to perform better? So what you found could have been the result of familiarization. Is it possible?
Basically, what we want to discover is that if we have some rearrangement of our coordination due to fatigue. So on the first day they performed the task 4 times, so they were able to understand different strategies in order to accomplish the task. So that means in the second day they found on the first day they found different strategies that use also on the second day.
Okay.
Well, thank you for the wonderful presentation. I have a question about the methodology that you used. So, did you extract the synergies with time as a factor or with angle as a factor? Because if I remember correctly, Torres Oviedo, the paper that you cited, did the reconstruction based on the angle as a factor instead of time.
We also use the angle for the different direction.
Last quick.
Henry Terry, Royal University, Bochum. Thanks for the talk. I was wondering if you compared this center of pressure kinematics between non-fatigued and fatigued, and did you see any differences?
Some performance at the level of the center of pressure. We don't have a significant results in the performance at the level of the center of pressure, like root mean square error. We don't have differences in the center of pressure. So the performance is the same.
Thank you very much. Well done.